Perimeter and areas of similar figures. To find perimeters and areas of similar polygons. First, whenever we have similar figures, we always have a ratio between the two. This ratio could be consistent of A over B, like this. The perimeter of the ratios does not change because it's one side length. However, whenever you take the ratios of their areas, you have to square the ratio. Why do we have to do this? Because area is going to be unit squared. It's a two-dimensional shape. It's not just one flat line. It's going to be the whole thing in between it. So that's why we have to square the ratio as well, just like how you square the sides of a square. So for the first problem, I have these two rectangles, and I have two side lengths. And they're in the corresponding sides, so those two side lengths would be compared, or written as a ratio. So the ratio it tells you is 6 to 8 or 3 to 4 because that's the reduced format. So it's saying what is the ratio, the smaller to larger, so smaller should be on top, of the perimeters. So again, the perimeter does not change. The ratio for perimeter does not change. If I were to, even if I knew this side length, if I were to add them all up and I had this number of the perimeter over this number of the perimeter, it's still going to reduce to 3 over 4. Now it's asking what is the ratio smaller to larger of the areas. Area is a little different. You have to have your 3/4 and this has to be squared. So when you square a fraction, you have to square both the top and the bottom, which would become 9 over 16. So this would be if I found the area of this shape and found the area of this shape and put it as a ratio, a fraction, the fraction would reduce to 9 over 16. Right now I want you to pause the video and attempt this next one by yourself. Be careful where it says larger to smaller. Your two answers should be 7/5 because 7 is larger than 5, so larger to smaller, larger should be on top. And your second answer should be 49 over 25 because you have to square both the top and the bottom for area of ratios. So this next problem, it says the area of the smaller rectangular hexagon is about this. This is the smaller one, the area. What is the best approximation of the regular? Well, we can use our ratio for area. So here's my side length for my small and large. Remember, small over large, the ratio of area has to be squared. So this could be 49 over 100. That's my ratio of my area. That's going to be equal to, my smaller is on top, 127.3 over x. I don't know what my area of my larger one is. But now I have a fraction equal fraction. So now I can cross multiply and get 49x is equal to 12,730 divided by 49. I want to get the area of the larger one would be roughly 259.8 feet squared. So the next problem, I want you to attempt it by yourself. This is already the ratio in between the two parallelograms, so it's the same process as the problem we just solved. And you should have gotten 54 inches squared. It says the larger polygon, so the larger number has to be matched up with the larger polygon. So you have to make sure to have your proportions set out correctly in order to get your 54 inches squared. So now I have a word problem. I still have to set up a proportion. So it's saying that my perimeter ratio would be 3 to 5. Now when I'm talking about how much a piece of glass would cost, like this, that's being the area of it. So I have to figure out what this ratio is, their area ratio. So 3 out of 5 squared, that's what I'm going to use. So just like the last problem, except this is more like a word problem. So 9 out of 25 for my area. The smaller piece is 250, so I have to make sure to put the 250 on top so it matches where my smaller piece is. And then cross, multiply, and divide, and you should get that the smaller piece, or the larger piece, would be $6.94. So this next problem can be a little bit more difficult, only because you have to find the missing pieces here. Now in this problem I'm given money, just like what we have been dealing with. I'm given the dimensions of a small rectangular room, and then saying what if that's 18 feet. First thing I want to do is look for my perimeter ratio. It's saying the larger dimension is 18 feet. This is for my larger. So you should use the length that's larger in your smaller room to figure out what your perimeter ratio is. So when I compare my small room to my large room, this is my perimeter ratio. So if I reduce that, both can be reduced by 6. So that's my perimeter ratio. Now this is just like the previous problem. I have to do 2/3 squared to figure out my area ratio, which would be 4/9. That's going to be equal to, I have to know where should I put the 150. Is the 150 dealing with my small room or large room? It's dealing with my smaller room. So asking how much would it cost for my large room? So now I cross multiply and divide, and I would get that it would cost $337.50. So finding perimeter ratio, working backwards now. It's giving me that this whole area is 10 feet squared, and I can figure out that this area is 160 feet squared, because 8 times 20 is 160 feet. So first I'm going to write out my area ratio, so 10/160. Now I can set that equal to, I have two side lengths, my small and my large. That's going to be equal to x/8 squared, because remember, it's the side lengths that would be squared gives you your area ratio. So now I can reduce or simplify this top proportion. So I have x squared over 64 is going to be equal to 10/160. I cross multiply here, and I get 160x squared is equal to 640. First thing you want to do is divide by 160, and I get x squared is going to be equal to 4. And now how do I get rid of something that's squared? I have to take the square root of it on both sides. So x is going to be equal to 2, because I cannot have a -2, because that would give me a negative side length. So I want you to do the next problem by yourself. You should have gotten 8.2 is equal to x, actually meters. So first thing you have to realize is that the 10 should be in the bottom, because it's saying the larger parallelogram has 10 meters. So that has to be matched up with your larger area. And then you have to square both the top and the bottom, cross multiply and solve, and you get 8.2. Make sure you took great notes and have a wonderful evening.